So let's take a look at student exercise number 5. And let's practice drawing Lewis structures of covalent compounds. If you take a look at BCl3, might be useful to highlight if there is an exception to the octet rule, so that way when you draw it, you don't make a mistake. The first thing you want to do is make it look symmetrical. I'm going to put the odd one, boron, in the middle, and I'm going to surround it by the chlorine. You could put this third chlorine above or below the boron, it doesn't matter. Then you're going to connect them all with lines. These lines are single bonds. They use 2 electrons each, so I used 2, 4, 6. Boron is in group 3A, chlorine is in 7A. So I had 3 electrons from boron plus 3 chlorine in 7A. That's 21 plus 3. I have 24 valence electrons to use total. I used 6 when I drew in my bonds. 24 minus 6 means I have 18 electrons left. I'm going to put the remaining electrons in pairs on chlorine, 2, 4, 6, 8, 10, 12, 14, 16, 18. The reason I didn't put them on boron is because boron was an exception to the octet rule. It only wants 3 single bonds coming off of it at any given moment in time. Okay, let's take a look at PF3. Put phosphorus in the middle, make it look symmetrical by surrounding it with the fluorine. Could have put this third fluorine above or below the phosphorus. Connect them with lines. Look at your periodic table. Phosphorus is in group 5A, fluorine is in 7A. 5 plus 3 times 7 is 21 plus 5. This means you have 26 valence electrons. You used 6, so we're going to subtract those. We have 20 electrons left to work with. We're going to put those 20 electrons on in pairs. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Phosphorus and fluorine, neither one of them are exceptions to the octet rule, so that's the proper structure. Now the next one is carbon dioxide. We're going to put the carbon in the middle. Put the oxygens on either side. Connect them with single bonds. Carbon's in 4A, oxygen is in 6A. 4 for carbon plus 2 oxygens in 6A is 12 plus 4. This is 16 valence electrons. I used 4, so now I have 12 electrons left. Put them wherever you want. 2, 4, 6, 8, 10, 12. Fortunately, we ran out. This oxygen is only surrounded by 6, so is this one. Carbon seems happy. I mean, it's surrounded by 8 electrons. So in order to make the oxygen happy, since I ran out of electrons to satisfy the octet rule, I'm going to move a pair over here. Now this oxygen is surrounded by 8. It's happy. And this oxygen is still unhappy, so I'm going to move a pair off of that carbon, put them here. Now this one is also surrounded by 8. That's the proper structure for carbon dioxide. Okay? Now, if we move on to the next one, it's NH4 plus 1. This is the ammonium ion. Anytime you are drawing a Lewis structure of an ion, it has to go in brackets, and you have to put this charge in the upper right-hand corner. So I surrounded the nitrogen with hydrogens to make it look symmetrical. Connect them all with single bonds. Nitrogen is in group 5A, hydrogen is in 1A. Remember, you do not use the hydrogen above group 17, above the fluorine, or above group 7A, okay? We have 5 plus 4 hydrogens in 1A. This plus 1 charge means I really lost 1 valence electron, so subtract 1 from the total. That will give you 8 valence electrons to work with, but I already drew in 8. So I have no electrons left, which is fine. Nitrogen is satisfied but with the octet rule. Hydrogen is connected with single bonds. We're good. Put this in brackets, put the plus 1 outside. Okay? Now, For the next one, we're looking at NH3. Put nitrogen in the middle, surround it with your hydrogen. Connect them with single bonds. This is in 5A, this is in 1A. I have 8 valence electrons to work with total. I used 6. I have 2 left. Hydrogen is an exception to the octet rule. Do not put it on the hydrogens. Put it on top of the nitrogen, so it's surrounded by 8. The next one is CH4. This is methane. Put the carbon in the middle. Surround it with the hydrogens. Connect them with single bonds. Carbon is in 4A, hydrogen is in 1A. You're going to end up having 8 valence electrons to work with. I already drew in 8 with my single bonds. I don't have any left. That's fine because hydrogen is an exception to the octet rule, only wants a single bond. Carbon is surrounded by 8, it's happy, and we're done. CCl4. Carbon in the middle, surround it with your 4-chlorine, and what you're going to do is connect these all with single bonds. Carbon is in 4A, chlorine is in 7A, so this is going to be 4 plus 4 times 7, 28, 32 valence electrons. You used 8. You have 24 electrons left. Put them on the chlorine. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 20, 22, 24. So everything is surrounded by 8 electrons. There's no exceptions there, and you're done. Then you have SO3 negative 2. Sulfur in the middle. Surround it with your 3 oxygens, connect them with single bonds. Sulfur and oxygen are both in group 6A. So you have 6 electrons for sulfur, 3 oxygens in 6A. This negative 2 means you gain 2 electrons, so we have to add 2 to our total. 18 plus 2 is 20. We have 26 valence electrons to work with. I used 6. 20 left. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is an ion. This goes in a bracket with the negative 2 charge in the upper right-hand corner outside. Then we have CS2. Carbon in the middle, sulfur is on either side. This is in 4A, this is in 6A. 12 plus 4, we have 16 electrons to work with. I used 4. When I drew my bonds, I have 12 left. 2, 4, 6, 8, 10, 12. Carbon's happy, surrounded by 8. Sulfurs are only surrounded by 6. So I'm going to move a pair off the carbon, create a double bond here because now this is surrounded by 8. I'll take this pair, put it here. Now this sulfur is surrounded by 8. That's the proper Lewis structure for CS2. Now for BeCl2, Be is going to be in the middle, chlorine on either side. Connect them with single bonds. Be is in group 2A. Chlorine is in 7A. So it's 2 plus 2 times 7. We have 16 electrons. I used 4. 12 left. 2, 4, 6, 8, 10, 12. Why am I not putting them on the beryllium? Because beryllium is an exception to the octet rule. It only wants 2 bonds on itself at any given moment in time. Okay? Then you have BH3. Boron in the middle, surround it with your hydrogens, connect it with single bonds. Boron is in group 3A, hydrogen is in 1A. 3 plus 3 times 1, you have 6 electrons to work with. Didn't I already draw in 6? I don't have any more. Boron and hydrogen are exceptions to the octet rule. Boron only wants 3 single bonds on itself at any time, therefore we are done. Then you have Cn negative 1. C goes next to N, connected with a single bond. 4 plus 5, we're going to add 1 electron because of the -1 charge. I have 10 electrons to deal with. I drew in 2. I have 8 electrons left. 2, 4, 6, 8. I have to share a pair here because I ran out of electrons to put 8 on everything. This nitrogen is surrounded by 8, carbon is not. Take another pair off, put it here, make a triple bond. That's the proper structure. Now each one is surrounded by 8. Put it in a bracket with the -1 outside because it's an ion.